Hi Andy, good morning. This is again Dr. C.H. Kiran Kumar dealing you the machine learning subject. Right, today we learn what is called distance-based machine learning. Distance-based machine. What do you mean by distance? So what we know till now is in a two-dimensional point, there is a x1, y1 and x2, y2. The distance between these two is called, generally, so it is called as x2 minus x1 whole square plus y2 minus y1 whole square root of. So this is one type of distance. The other one is y2 minus x2 whole square, y1 minus x1 whole square. So this is another type of distance. Now, why we need all distance metrics? Why we need all distance metrics? Let us see now. Now, the main point here is how we use this machine learning, in this machine learning, the distance points. How? See, this is. Let us see an example. For suppose there are plus, 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 minus, 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 something like this. Some plus, some minus. Right. Now, we want to classify another plus. Say, for example, there is a plus here. I want to classify a point here. I want to classify this point as positive or negative. This is the question. Right? I got a point here. I got a point here. I got a new one is here. Now, whether it is plus or minus. Now I want to classify. How do I predict this? Whether I correctly predict it or wrongly predict it, that's a different story. But how do I predict this? This is what I want to predict. Now, for this, I am going to use distance-based machine learning. How I use distance-based machine learning? Right. I calculate. I consider the nearest neighbors. See, this is a nearest neighbor. This is again a nearest neighbor. This is, and this is a nearest neighbor. Now, you take 5 or 6 or 7 or 8, for example. No, k instances. You take k instances. Now, ఈ అన్నిట్లో majority, you take majority or voting. This is also called as voting అంటారు. అంటే ఎక్కువ ఎవరికైతే ఎక్కువ ఉన్నాయో వాళ్ళని సెలెక్ట్ చేయటాన్ని ఓటింగ్ అంటారు. సో ఈ విధంగా distance based, this is called distance. ఏదైతే ఎక్కువ ఓటింగ్ ఉందో you take this as, predict this as, now in case law you have to predict this as minus. For example, if you have a thing like this, then you will be predicting this as plus. If you have a thing like this, now how do you predict this? This will have equal distances. Now, whichever is having voting means even one vote unna kuda extra, that will be predicted like that. This is where we use distance, my dear friends. Now, many distances are distance, right? For example, if you take, what is the distance between a point to this point? No, this is road distance. There will be rail distance, air distance. What is road? No, you have to no, you have to reach the destination from source via the available road only. Available road only. You can't go, no, like if you want to, for example, if you want to, no, if you have a mountain here, how do you travel the mountain? You can only travel just by, you have to go like this. Then only you can, but if it is through air, no, if you take 2 hours to cross a mountain, through air, it can be crossed within just 2 minutes. So this is how distance-based machine learning. Now, even if you can take a chessboard, normally chessboard 64 boxes, and now if you take one each, if you take a rook, see, if you take king, what are the moves of a king? If the king is here, he can move. These are all the possibilities of king. Now, if you take another, for example, if you take a rook, if this is the rook, so it can go this way, or it can go this way, or it can go this way, or it can go this way. At a time, any number of moves can be made by this rook. Any number of moves, but only horizontal or vertical. So, rook. So, this is also called distance. So, all these things. Similarly, if you consider bishop, if you consider a bishop, it moves diagonally, bishop, diagonally. Now, so this is about distance-based machine learning. The main idea is how do we use this distance metrics in our machine learning. This is the main idea. See, this is the main idea, my dear friends. Nearest neighbor. Nearest neighbor. Nearest neighbors. So we are going to learn this distance-based machine learning now. Now in the first phase, we will be learning the different types of distance metrics we have. In general, we'll just have just a definition. We'll just describe the definitions and all. After that, we'll be learning nearest neighbors. Right? Let us go. Right. Minkowski distance in n-dimensional space is defined as Minkowski. Consider 2 points P1, P2 on n-dimensional space or d-dimensional space, whatever it is. If it is d-dimensional, this is given as n-dimensional, whatever it is. Right here, the distance between, if it is a 2-dimensional, which is x1, y1. So point P1 is x1, point P1 is x1, x2. Instead of, see, point P1 is taken as x1, x2, point P2 is taken as y1, y2, my dear friends. Please remember this. Right, now we take the distance between x1, see, x1 minus y1, x1 minus y1 whole power p, x1 minus y1 whole power p, x2 minus whole power p, xn minus yn whole power p. What is p? See, if it is a two-dimensional, we write it as 2. That is square root of x2 minus x1 minus y1 whole square plus x2 minus y2 whole square root of. If it is a three-dimensional space, we used to write it as 3 root x1 minus y1 whole cube plus x2 minus y2 whole cube plus x3 minus y3 whole cube. See, this is how it is. In this way, if you go and write, the final formula would be disp p of xy is equal to, where x is x1, x2, x3, x4, x5, xn. The first coordinate, y is equal to y1, y2, y3. There are 2 points, my dear friends. P1 is another 1 point and P2 is another point. P1 point is x1, x2, x3, x4, x5. It is not, my dear friends, xy. X coordinate, y coordinate కాదండి ఇక్కడ. అన్ని x1, x2, x3 and y coordinates are y1, y2, y3, yn. So in this case, so we can write this as, see, normally we write this xj minus pj, yj, that is x1 minus y1 modulus of x1 minus y1 whole power p, but summation of j is equal to 1 to d, where d is dimension, and whole power, the square root can be considered as 1 by p. So that is how, so this, if you convert this, you will get p root. So can be written as modulus of x minus y base p, So this is called Minkowski distance అని అంటారు. General ga the value of p is either 2, 3 or 4 for most problems, because we cannot go beyond the 4 dimensions, right? Oh, this is called Minkowski distance metric. Now coming to the Euclidean distance. Euclidean, what do you mean by Euclidean distance? See here, if you take 2 points here, P1, Q1, P2, Q2, P1, Q1. So if you take this Q1 minus P1 whole square and Q2 minus P2 whole square, Q2 minus P2 whole square. Now if you take x1, x2 in y2, y1, y2 తీసుకుంటే, then we can call this as xj minus yj whole square. This is called distance to, this is called Euclidean distance. Euclidean distance. Euclidean distance. This is Pythagoras theorem. By using the Pythagoras theorem, we used to calculate this. Right. This is called distance between 2 points. P2 minus P1 or P1, Q1 minus P1 whole square, Q2 minus P2 whole square. So this is called Pythagoras or Euclidean distance. Now coming to the Manhattan distance, there is another term called as Manhattan. Manhattan distance is, it is the distance between, without squares, See, just like xj, right, again, in a plane P1 with at x1, y1 and a plane P2 at x2, y2, it is x1 minus x2 plus y1 minus y2. See, normally this is the definition. But here we have taken it as x1, x2 and y1, y2. In this case, what we call this as, right, x1 minus y1 and x2 minus y2. See, this is general. See, x1, y1, x2 minus x1, y1 minus y2. In this case, we take this x1 minus y1 and x2 minus y2 without squares. This is called Manhattan distance. This is called as xj minus yj, modulus of xj minus yj. Manhattan distance. Manhattan distance, my dear friends. So sigma j is equal to 1 to d. So we call it as sigma j minus yj. Remember, we have taken points as x1, x2, etc. xn. P1, this is P2 is y2, y1, y1. So anyhow, whatever it is, right? Next is Chebyshev distance. What do you mean by Chebyshev distance? Just in Manhattan distance, we used to take the sum of all differences of the dimensional differences. In Chebyshev, we will be taking only the maximum of maximum. That is called Chebyshev distance. Chebyshev distance. We will be taking the maximum. Right? In the same way, we will have another one, Hamming distance. What do you mean by Hamming distance, my dear friends? Hamming distance as the number of bits that need to be flipped to change x into y in a binary number system. That is Hamming distance 0, 1, 0, 0. See, 0, 0, 1, 0, 1. How many numbers are changed to transform this into this? You have to change this 0 as 0, no change. This 1 as 0, 1 change. And 0 as 1, another change, plus 1. And 0, no change. So the Hamming distance between these two are 2. What is meant by Hamming distance, my dear friends? See, in binary number system, the Hamming distance, this is called Hamming distance, my dear friends. Hamming distance. For non-binary strings, of unequal length, this can be generalized to the notion of edit distance or 11-seater distance. See, for non-binary strings, this is called Hamming distance, my dear friends. Hamming distance. Right. Mahalanobis distance. Mahalanobis is the father of statistics. That is why his name is given to Mahalanobis. See, this is defined as root of x minus y whole power t sigma inverse x minus y. See, this leads, often the shape of ellipse is estimated from data as the inverse of covariance matrix. M is equal to sigma inverse. So these are all the different types of distance metrics we have. Now, if you consider, we are all going to theoretical way, right? Disp P of xy is equal to sigma j is equal to 1 to d, where d is dimension, x modulus of xj minus yj whole power p, this whole power 1 by p, and represented this as x modulus of x minus 1 base P, where this is taken as ZP, this is taken as Z. So ZP is equal to modulus of ZP is equal to sigma J is equal to 1 to D X. So Zj whole power P. So this is the simplest way. So this is P norm, sometimes denoted as LP. This is called P norm. This P norm of the vector Z. Vector means components of this Z vector. Now we will often refer this disk P simply as P norm and P. So the 2 norm refers to the familiar Euclidean distance. The 2 norm dist 2 xy is equal to root of z equal to 1 to d xj minus yj whole square. It can be written as root of x1 minus y1 whole square plus x2 minus y2 whole square root of. So it is also written as root of x minus y whole power t into x minus y, which means distance, which measures distance as the crow files. 2 other values of p can be related to back to the chest example. The 1 norm denotes Manhattan distance, also called as city block distance, Manhattan distance, modulus of xi minus ya, just without square, is called Manhattan distance. Now some metrics on distance. Given an instant space x, a distance metric is a function dis from x to x, x cross x to r, such that for any x, y, z belongs to x, distances between a point and itself is 0. Distance of x comma x is 0. All other distances are larger than 0. If x is not equal to y, then distance of x comma y is greater than 0. Distances are symmetric, that is dis of y comma x is equal to dis of x comma y, because we have mentioned this modulus. And detours means long round distance. See, long round distance cannot shorten the distance, of course. Now dis of x comma z is less than or equal to dis x comma y plus dis x. See, x comma z. Suppose if you have points x, z, and if you have another y, so we can definitely say dis of x comma z is less than or equal to dis of x comma y plus dis of y comma z. This d1, d2, and if I say this is d3, definitely d3 must be in, detours kaakapote less than or equal to d1 plus d2. So these are all the distance metrics. This is also called as triangle inequality. Right, let us say the same, right? The triangle inequality means the distance from the origin C, to C. This is the origin. This is the origin to C. Origin to C is no more than the sum of the distances from origin to A. And A to C. B is at the same distance from A as C, C ki B ki approximate distance regardless of the distance measures used, distance of A plus distance of AC is equal to distance from B. So if we draw a circle around the origin through B, the triangle inequality dictates C is not be outside the circle. See, it is not outside the circle. As we see in the left figure, for Euclidean distance, B is the only point where the circles around the origin around A intersect. So everywhere else, the triangle inequality is a strict inequality. So this is how this is all the study of distances. We need to know some more terminology. We'll see now some more terminology, my dear. Right. Some more definitions. Let us see. Now, distance metrics, which can be Euclidean, Manhattan, Minkowski or Mahalanobis, among many others. What are meant by exemplars? Exemplars. Centroids that find a center of mass according to a chosen distance matrix, or medoids that find the most centrally located data point. See, centroid exemplars are the methods. Exemplars are methods. Centroid is one of the methods, center of mass. And medoid is the one which is most centrally located data point. Now, where we use centroid, where we use medoid. Let us now see distance-based decision rules which take a vote among the k nearest exemplars. Right? We will see all these definitions, my dear friends. Now, in general, Manhattan distance like this and Euclidean distance is like this. Okay. Hope you understood, right? Now, right. Distance is applied through the concept of neighbors and exemplars. Neighbor and exemplars. Who are called neighbors? Neighbors are points in proximities with respect to the distance measure expressed through exemplars. Right. Neighbors are the points in proximity with respect to the distance measured expressed through exemplars. For example, so if point is there here, now another, so these are all the, so which one is called neighbor? See, who are called neighbors for this? Neighbors, ever nan pilustam. See, neighbors are the points in proximity with respect to the distance measure expressed through exemplars. Exemplars are methods which explain you how to measure the distance. These then you can derive what are called neighbors. Exemplars are either centroids. Exemplars are either centroids that find a center of mass according to a chosen distance metric, or medoids that find the most centrally located data point. The most commonly used centroid is the arithmetic mean, which minimizes the squared Euclidean distance to all other points. Now, squared Euclidean distance. We use centroid. Right? Let us see what do you mean by exactly centroid. But the centroid represents the geometric center of a plane figure, that is the arithmetic mean position of all the points in the figure from the centroid point. This definition extends to any object in n-dimensional space. Its centroid is the mean position of all points. Mean position of all points is called centroid. Mean position of mean position of all points is called centroid. See, centroid of a triangle is there, centroid of a rectangle is there. See, mean position, right? Mean position of all points is called centroid. Right. What do you mean medoids are similar in concept to the mean of centroid? Medoids are most commonly used on data when a mean or centroid cannot be defined, my dear friends. Cannot be defined. They are used in context with where centroid is not representative of the data, such as image or natural processing or no speech recognition. Somewhere it will be used. Hope you understand now what is called centroid. Centroid is mean position of all points. Mean position of all points. Medoid means where centroid cannot be calculated, or centroid is the arithmetic mean, right? You can again define the arithmetic mean mu of a set of data points D in a Euclidean space is the unique point that minimizes the sum of squared Euclidean distances to those data points. The arithmetic mean mu. The arithmetic mean mu of a set of data points D in a Euclidean space is the unique point that minimizes the sum of squared Euclidean distances to those data points. Let us see this. See, this is called Euclidean mean. See, the geometric median of a discrete set of example points in Euclidean place is the point minimizing the sum of distance to the sample points. For example, if we consider these are all the sample points, 1, 2, 3, 4, 5, 6, something. These are all the sample points. If we concentrate to calculate the median, this would be the median. See, which has the property of, right, same. No, how it is calculated means this is calculated like squared mean, right? This distance is squared, all distances are squared, and then take average, and then you plot it, you'll get this. This is called geometric median, my dear friends. Geometric median. Hope you understood. Geometric median. So these are all called the different terminology of the distance-based machine learning. Distance-based machine learning. The main important is neighbors and exemplars. Neighbors and exemplars. Neighbors are calculated by neighbors. Generally, neighbors are the aspas or neighbors means around. Nearest points are called neighbors. But how do you say nearest? What is the metric you are going to use to say nearest? That is nothing but exemplar or centroid, or either centroids that find a center of mass according to a chosen distance metric, or medoids. Now, where centroid cannot be applied. Exemplars are only two, centroid and medoid. Right? Hope you understood. Centroid means very simple. Centroid. This is called centroid, my dear friends, or arithmetical. Centroid means median, geometric median. Also, we can say, right? So this is what right mu is. Hope you understood. This is all terminology of the distance-based machine learning. We will see in the next class.